Question 17 asks you to solve a quadratic. Now normally your first instinct would be to try and factorise it, try and put it in brackets and solve it from there. But the fact that it tells you to give your answer in this form with a surd in it means that you're not going to be factorising it. It's not going to come out as a nice whole number or a fraction. And when you see this, there's actually two ways of doing it. One is to use the formula, which looks like that. Worth remembering. Now in this case, the coefficient of x squared, a is 1, b is minus 6, and c is minus 8. So I've got minus b, well if b is minus 6 then minus 6 is just 6, plus or minus the square root of b squared, which is 36, minus 4 times 1, no point in times in by 1, so minus 4, a is pointless because it's a 1, so minus 4 times minus 8, all over 2a, which is 2, so that becomes 6 plus or minus the square root of 36, a minus and a minus gives you a plus, so that's 36 plus 32, 36 plus 32 gives you 68. Right, a and b have to be integers, so you're going to have to manipulate this surd a little bit. I don't know why I always write this big and run out of space. If I borrow a little bit of room over here, root 68 can be written as root the biggest square number that goes into 68. Well, 4 goes into 68. 16 doesn't. Nothing else bigger than that. So we'll do root 4 times by, how many times does 4 go into 68? 15, 17. Okay, so it's this idea that if you've got the square root of like 90, there's no benefit for doing this because you can only really simplify it if one of them's a square. In fact, you can simplify that. That would be the same as root 9 times by root 10, using one of your laws of surds. So root 9 is 3, and you could simplify that to 3 root 10. So in this question, doing something similar, if I change root 68 to root 4 times root 17, because root 4 becomes 2, I can now divide 6 by 2, which gives me 3, plus or minus, and 2 divided by 2 just gives me 1, so they cancel out. So you can simplify it to 3 plus or minus root 17, which is your final answer. It's in the form you need it to be in. So if you're a little bit rusty on the laws of surds, how I've got from there to there, then look it up. And the reason why I can divide this bit by 2 and then this bit by 2 is because they're separate terms, because they're separated by a plus or a minus. So it's a bit like, if you've got 3 plus 2 over 7, that is the same as 3 over 7 plus 2 over 7. They both give you 5 over 7. So that's why I can separate, I can think of that as 6 over 2, and then plus or minus 2 root 17 over 2. That's why I can divide them both by 2 separately. Second way of doing this, if you actually complete the square, so half of your b value goes in there, I subtract the square of this number, so the square of 3 is 9, and I've still got that minus 8 on the end. If I complete the square of this and put it in this format, you get x minus 3 squared minus 17 equals 0. I can add 17 to both sides. I can square root both sides, and because I've square rooted it becomes plus minus. And if I add 3 to both sides, it ends up looking the same. So if you can't factorise a quadratic and you need to solve it, you can either do it by using the formula, which I've shown coming up to this point, or if you complete the square and gradually rearrange it, you can also get to the same point. Pause this, watch it again, try and get your head around at least one of these two methods. Okay, actually let's do question 18 at the same time. So it tells you that this area PNQ is 8 centimeters squared. And it tells you that this area LPQ is 16 centimeters squared. Now, because this, you can think of this as being the base of both triangles, because that is the same for both of these, the only way this area can be twice as big as this area is if PL is twice as big as PN. So if this bit is twice as big as this bit. So this is the same as 2 lots of PN, it's twice as big as PN. Now if that's true, then N to L, this whole thing, because you've got 1 lot of N to P and then you've got another 2 lots of N to P, this is twice as big. This whole side down here must be 3 times bigger than NP. Because you've got that and then you've got a side that's twice as big. So the whole thing must be 3 times bigger than NP. If you look at these, because you've got this little triangle and then you extend it, the angles in this little triangle are the same as the angles in the big triangle. What I'm trying to say is this little triangle is a similar triangle to this big one. All the angles are the same, it's just that this is a smaller version. So to get from this little triangle to the big triangle, you've got a length scale factor of 3. The side length of the big triangle is 3 times bigger than the side length of this bit. So you've got a length scale factor of 3. So the area scale factor is going to be 9. So if the area of this small triangle up here is 8, the area of the big triangle, we can use the area scale factor. So the area of the whole thing, NLM, triangle NLM, gone off screen a bit. The area of triangle NLM is 9 times bigger than the area of NPQ, so 9 lots of 8 centimeters squared. Now the question doesn't actually ask us for the area of this whole thing, it asks us for the area of triangle LQM. So I just want this shaded bit here that I'm going to try and lightly shade. So if the whole thing is 72, if I get rid of the 16 and then I get rid of the 8, that leaves me with 48 centimeters squared. So, quick summary, if the area of this is twice as big as the area of this side length, because they share the same base, the area being twice as big must come from this side length being twice as big as this side length. So therefore, this whole length down here must be 3 times bigger than this length here. So if the length scale factor between this triangle and this big triangle is 3, the area scale factor must be 9. So times in this 8 by 9 gives us the area of the whole thing, and that's how we end up manipulating it to get our final answer.